All right, final exam review for precalculus. So I'm just going to review some of the types of questions you can expect to see on the final exam that you can find in ALEKS. So write an equation in slope-intercept form given a slope of 2/3 and a y-intercept of 3. So for these type questions, don't overthink it. You're just plugging in your slope and your y-intercept. Okay. You had a section that dealt with quadratics. So this question says find all complex solutions of the quadratic 2x squared minus x plus 6. To solve this, you will need to use the quadratic formula. Where a is your lead coefficient of x squared, b is your lead coefficient of your linear term, and c is your constant. So this gives us -1 plus or minus the square root of -1 squared, which is 1, minus 4 times a times c, divided by 2 times a. So 1 plus or minus the square root of, we have a 4 times 2 is 8, 6 times 8 is 48, so 1 minus 48 gives us a -47 all over 4. So you can see you have a negative under the radical, so that tells us this is a complex solution. So we're going to rewrite that as 1 plus or minus square root of 47i, because remember I is equal to the square root of -1, and then each is over 4. Notice I separate these fractions because you want to be able to identify your real component and your imaginary component. Okay. We had a section that dealt with exponential functions. So let's say that we have a rate of inflation of 4% per year for the future price in dollars of a certain item, and it can be modeled by this equation. Find the price of the item in 8 years. So we would plug in 8 for t and solve. Okay. We had a section on, trig functions. So find the exact value of sine 5 times pi over 3. So anytime you see the words exact value in a math question, that's saying don't use a calculator. So notice that pi over 3 is we could use one of our special right triangles, because pi over 3, those of you that think in degrees, pi over 3 is equal to 60 degrees. So that tells us we're going to be working with our 30, 60, 90 triangle. So pi over 6 is 30, pi over 3 is 60. So we're looking for the sine of pi over 3. We'll deal with this 5 in a second. So sine of pi over 3 is equal to opposite square root of 3 over hypotenuse. But we need to see, where does 5 pi over 3 land on the unit circle? So 5 pi over 3 is the same as saying 5 times 60, so 300 degrees. So that lands here on our unit circle, which gives us a 60-degree reference angle. Okay, so in this quadrant, sine is negative. So you want to make sure that your answer represents that, because remember, we have our everything positive in the first quadrant, sine and cosecant positive in the second, tangent and cotangent positive in the third, cosine and secant positive in the fourth. So let's just go through that one more time. So pi over 3 is equal to 60 degrees. 5 times 60 is 300. So on our unit circle, we always travel counterclockwise. Unless we're given a negative in front, then we know that we go clockwise. So that's telling us that our reference angle, which is the angle that it always makes with the x-axis, is 60. And again, we know opposite 60 is root 3. Opposite 30 is 1. And then opposite over hypotenuse, square root of 3 over 2. All right, another trig question. Let theta be an angle in quadrant 3. So theta is in quadrant 3. And cosecant theta is equal to -5 halves. Find the exact values of tangent theta and cosine theta. So the first thing we want to do is graph. And actually, I'm going to use -4/3. Okay. So the first thing we want to do is plot these, is graph this. So it says third quadrant, so we already know where we are. So we know that's our reference angle. Cosecant is the same as its reciprocal function, 1 over sine of theta. So sine is opposite over hypotenuse, so cosecant will be hypotenuse over opposite when we're looking for those ratios. So the hypotenuse we know is 4. We know the side opposite the angle is 3. So now we need to determine this side right here. So we'll use the Pythagorean theorem. 4 squared is equal to 3 squared plus we don't know squared. So that's 16 minus 9 is equal to x squared. So that gives us square root of 7. So before we look at these ratios, we want to think about, okay, what's positive in the third quadrant? All students take calculus. So in the third quadrant, tangent is positive. So I know my answer to tangent is going to be a positive answer. So tangent of theta is equal to opposite over adjacent, so 3 over root 7. Cosine of theta, cosine in the third quadrant is negative, so I know that I'm going to have a negative answer here. Negative adjacent square root of 7 over hypotenuse, 4. Okay.